This conference will now be recorded.
All right. Thanks all for joining the bi-weekly Door Heat Exchanger call. Like I was saying before we started the recording, apologies in advance for not sending out the agenda a day ahead of time. But I do appreciate everyone who did join the call. So let me share my screen. Okay. Can everyone see my screen?
Yes.
All right. Thank you.
Yeah.
So a couple of things to note for today's call. First is, last call we talked about the regional summit, which took place in Prague. I believe that was fairly successful. Now that that's in our rear view mirror, the call for presentations for the global summit has just gone out. So I've attached a link over here in the meeting notes. And I've also included details in the agenda document, but effectively, um, you know, um, the cooling environment subproject is soliciting presentations, as part of the engineering workshop at the Global Summit. So in the Door Heat Exchanger community, I think starting today, we should have conversations about what should be presented at the Global Summit. I also feel like this year there's been a lot of efforts that have been kicked off. So it's going to be an interesting Global Summit. I think there are going to be lots of updates from multiple areas, as opposed to the usual where it's predominantly immersion. So within this community, between now and June 16th, let's talk about potential topics that we'd be looking to submit as part of this call for presentations. And then, as you can see over here, the Global Summit is going to be in mid-October. So, the initial submission and review process will be leading up to, late September, as shown over here. And probably, as is the case with previous global summits, presentations will be gauged based on two factors. One is whether it's based on an ongoing submission or something that's already been reviewed with the incubation committee or the necessary groups. Or the second thing is, it's a contribution that's come through the sub projects, but it's potentially something that could be very interesting to the general public. So that's not to say that the only way of having a presentation accepted at the Global Summit is if it's an ongoing OCP contribution, because we do make exceptions, especially when it comes to very interesting topics like panels about standardizing the coolant supply temperature on the technical water side, or so on and so forth. So as I said, between now and June 16th, we should have conversations about which topics we'd like to contribute from the Door Heat Exchanger community. I know there are lots of cross-functional efforts that are ongoing. Like I know, Mike, you're involved in the hardware on the cooling hardware management side. I'm not sure if that's something that's been concluded already or is planned to be concluded by the global summit time, but that could potentially be a topic. I know Jabari is helping drive the concurrent maintainability effort as part of ACS. So there are a bunch of things that are ongoing. So yeah, so within the Door Heat Exchanger community, we do have a bunch of new topics that have been, that are in the planning stage currently, like modular data center, hybrid cooling for modular data centers. Um, there was also conversation about reference designs for heat exchanger deployments. Um, that's an area that needs to be followed up on with ACF and Vertiv. We also have the conventional coil versus aluminum microchannel white paper. And then there's the facility door heat exchanger effort that's been proposed by Meta. So we do have a few topics that will definitely be in the um, in the running. One thing I did want to ask the community is that, is there anything else from your perspective that you know uh, that any of the attendees would love to see, or would like to submit through the door heat exchanger work stream? Anyone?
John, I have a question. You are asking about the topics we spoke below, before, if we agree with to write a white paper or something like that?
So this is more along the lines of, if there's something that you want to present at the global summit. I'm asking if it's beyond the topics that we have been discussing in the past few weeks, or planning the past few weeks. I just want to know if there's anything from the community that needs to be captured.
The only thing I can
go ahead, Chakmani. Sorry.
The only thing I can, well, not the only thing. So I know we discussed the radar heat exchanger specification revision. I don't know if that qualifies as a presentation, or that's just an update to a document. So that's one. That's probably I know we had some initial discussions about it that we could probably drive and hope to have finished by the 25th of August for submission.
Right. So basically, revision 2 of the requirements document.
Yeah.
Mm.
I know I haven't looked into the various updates yet. That was on my list and I just kept putting it off. So I'll look into it again, because I know I told you I would when we discussed it. So that's one potential. In terms of the concurrent maintainability, we haven't gotten there yet, but in terms of talking about radar heat exchangers. So once we get there, that is going to be the second topic after cold plates. I'll see if there's any material there that can actually lead to. So we can, I guess, do a deep dive in this group and come up with a presentation for it. So maybe I'll let you know about that when we get there, right? Okay. So that's probably going to be next month. What I did think was the hardware management, because I know we did talk about it in the last white paper. We kind of left that one, we summarized it, but we didn't. There was a lot of controls and stuff that went into it, depending on the configuration of the radar heat exchanger, if it was ALC, air assisted or hybrid. And I know Mike had a lot of thoughts about it. So I think maybe we should ask between. Yeah, I don't know if Michael thinks that there's enough material there for a presentation specific to the hardware management of a radar heat exchanger.
I don't know whether it'll actually be covered in here or whether it'll be covered in the OCP hardware management group.
Okay. There's nothing. Okay, I see what you're saying. It kind of goes into that realm. All right. Yeah, you're right.
Yeah.
Okay.
Yeah. So there is an entire track talking about hardware management. So Mike, what you're saying is, the effort that you've been involved in, which is related to hardware management for cooling, you think that will probably be covered under this separate track?
Yeah, probably, because it would also include interface to facilities and CDUs and heat reuse and everything like that. That's all liquid cooling related. is being done under hardware management.
Mm-hmm. I see. Yeah, and I know Mick has been leading that, so yeah. Okay.
I would imagine that they'd be very interested in somebody from this group reviewing whatever presentation gets created on that to make sure that they're not misinterpreting our needs for hardware management.
Yeah, I also get this. I don't want to say sneaky feeling, but I also get the feeling that there might be a push to do a cooling specific presentation when it comes to hardware management, because I think there'll definitely be a lot of interest with attendees who are probably going to be spending most of their time in the cooling environments track as part of the engineering workshop. So, I wouldn't be surprised if Mick and Rolf decided to, put in a submission to talk about hardware management for cooling devices or cooling components. Yeah.
In terms of hardware management, do they go to the depth that we did, where we actually looked at percentages? We ran some models and looked at what kind of savings, power efficiency and stuff you were getting based on different configurations? Or is hardware management looking more at recommendations for, I guess, how systems should be set up? They're not looking at like samples or examples of performance that can be expected.
Yeah, I think you're talking about a use case versus the implementation aspects of the hardware management. I think they're more interested in the implementation, so that they would define sensors and controls and things. And as long as they have the appropriate sensors and controls that we would need for a heat exchanger, then we're happy from that perspective. But from a implementations perspective, you would have specific values for sensor thresholds that would be appropriate that the hardware management guys don't really care about. They don't care what the specific numbers are. That's an implementation issue. So it might be entirely reasonable to do a presentation from this group that is on the use of hardware management instead of the implementation of hardware management.
Yeah, or it could be something like, hey, here's the redfish. Here are the redfish definitions, that have been, and I'm assuming redfish is still the basis of all, the hardware management implementation, right, Mike?
Yes.
Right. So it could be like, oh, hey, here's how, this entire redfish framework was implemented for Doe heat exchanger. And if a vendor is all in on, going with OCP and using the same, hardware management definitions, then potentially it could be a presentation that says, hey, we implemented this and, we found this to be great. And, here's some feedback we received from some customers. I think that would be a great presentation, but I'm not entirely sure if, the entire hardware management for cooling, has been, already completed and documented as part of the work that Mike's been involved in.
No, it's far from done. The other thing is that there is hardware management from the server's perspective that covers things like cold plates. So you would have a sensor on a cold plate that has needs for cooling, but can't do the cooling. It depends on a CDU and a heat exchanger and other things. And you've got a CDU that needs to be managed. You've got a heat exchanger that needs to be managed. You've got facilities that are providing the cooling. And all of this needs to be tied together somehow if you're doing a hybrid implementation. And the hardware management crew doesn't really care how you do that, because that's an implementation issue, not a specification issue. So as long as they provide all of the hooks for you to talk to and control all of these devices, they're done. But now it gets to be a specific implementation issue as to how you tie them all together. So, that might be an interesting presentation, is using, like you said, this management framework in a potential application. So how would you do hybrid cooling within a cabinet, and how would you manage the whole thing?
I think it also helps in the future reference documents for liquid cooling. If we had, these kind of analyses and numbers to put with the implementation numbers to put next to a technology that's being considered.
Right, and
So
the hardware management people don't. Yeah, the hardware management people don't care about what the actual coolant temperature or sensor thresholds are, as long as they're capable of being implemented and read. And
yeah,
from
I think the focus is more on, if you had to deploy a certain cooling component, let's say a door heat exchanger, then has the hardware management group basically enabled all the hooks, as Mike calls it, so that the door heat exchanger supplier can say, you know what, everything that I needed to enable my door heat exchanger solution is already a part of this framework that's been defined. Right, Mike? So it's all about just making sure that the features are available as opposed to how they are implemented.
Right, but it's a completely separate issue. It is trying to use the management to do something.
Right.
And that might, from our perspective, doing something on hybrid cooling would be by far the most complicated version of this, and it might actually be pretty interesting.
True, yeah, because that would involve controlling multiple devices.
Yes.
Like you said, the CDU, the door heat exchanger, and then depending on the location of the CDU, it actually becomes even more complicated. Because if it's a row level CDU, it may not make sense to get, to tie in temperature readings from individual cold plates. But if it's an in-rack CDU, then you could potentially make the case and say, well, I'm focused on making this zone. If you define a rack as a zone, my focus is making this as energy efficient as possible, right? And energy efficiency can mean different things. It could be increasing the return water temperature, or so on and so forth. So yeah, it just depends. Yeah, and then if you tie in the facility, then it becomes way too complicated. But that could be something interesting that someone could look at and come back and say, hey, we tried to implement this, and here's what's great, and here's what really sucked, and can we take a look at this? So yeah. All right, awesome. Any other takers in terms of potential topics? Jabari, we can definitely follow up on Rev 2 of the requirements document. And I know you're busy with concurrent maintainability right now, so I'll wait on you to, get in touch and, and then we can figure out next steps.
Sure, no problem.
Okay, if there are no further inputs on this, we can move on to just a quick update of progress on other areas. One is I somehow missed the monthly modular data center sub-project call, but I know Jabari did, was able to make it, so thanks for doing that. But I do need to coordinate with Carl and start setting up the offline discussions, work on the white paper. And for those of you who are curious to know about this, there's a link in the document to what's been outlined and who the potential POCs are. So I just need to follow up with Carl on this. Let me just post a link to the meeting notes in the chat thread so everyone can have access to it. So sort of related to that, I've been having an offline conversation with Philip from Boyd. And this is more along the lines of requesting engineering support, for contributions that involve, talking about door heat exchanger performance. So I'm not sure if everyone's aware, but in the past, in the past we did have um, a lot of data that came from the Boyd team that was involved in the white paper where we talked about the limitations of door heat exchangers in different applications. So the intention here is to have similar support from Boyd that would enable us to uh, support these white paper contributions. So specifically over here, I'm talking about the hybrid cooling for modular data centers. So that would be one area where we definitely require some support because we're talking about 25, 50, and 75 kilowatt hybrid cool racks. And the second one is the white paper where we'll be comparing the conventional fin tube type door heat exchanger coils with the aluminum micro heat exchanger coil variant. And we definitely need some data on the conventional fin tube type coils. The aluminum microchannel heat exchanger data will come from Danfoss. So yeah, anyway, I need to follow up offline with Philip. And actually over here, Juan Carlos and maybe Jabari, if I can get you guys assistance over here in terms of framing the information we need, I definitely appreciate you guys' support with that. So
Yeah, no problem.
okay, cool. Then I'll set up an offline conversation early next week to maybe start
Yeah,
drafting those requirements, and then I'll also include Philip so he can take a look at it, and then we can follow up accordingly. So thanks, guys. And then I've been sort of busy the last 2 weeks, but there are a few contributions that have been sort of initiated this year that sort of need to build some momentum in addition to the modular data center white paper. And then on these, I need to determine the next steps. I think one of them is the reference design for door heat exchanger deployments. And this is with ACF and Vertiv. And I know, Benny, you've kindly sort of, offered to support over here. Actually, Benny, can you hear us?
Yeah, I'm here.
Hey, with regards to that, I know the next step was to have a conversation of some kind with OCP about what a reference design looks like, right? If I remember correctly.
That's right.
Okay. I'm not sure if you sort of join other OCP cooling environments calls, but do you mind helping me out over here and maybe pinging the email thread and asking about, hey, what are the next steps? Because, I really appreciate your support over here in terms of helping to drive this effort.
Okay. Okay, yeah, I can do that. I wasn't sure what, I know the last we had talked, we were supposed to get together for a meeting, but then I believe everyone was in Prague for the conference that week. And so I think it just got kind of lost in there. So I'll reach out again and on that email thread and go from there.
Yeah, I appreciate that. And I know you also checked internally and sort of provided a document as reference. I believe it was what Vertiv considers as the format for a reference design.
Right.
I think that was great. I think if you can also sort of include a copy of that and say, hey, just as reference, here's what Vertiv uses when it defines reference designs, and we're happy to provide this as reference. If OCP wants to use this as a baseline to, set up this template or something like that.
Okay. All right. Sounds good.
All right. Awesome. Thanks, Benny. And then the next one was the white paper on comparing the conventional fin tube and aluminum microchannel coil variants for door heat exchanger applications. solutions. I need to follow up with Sankar on that, with Danfoss. I believe this one's probably going to be, this one can be a pretty straightforward one. But like I said, we do need some support from Boyd in terms of, getting some fin tube oil sizing calculations. And then finally is the facility door heat exchanger effort that's been proposed by Meta. On this one, I'm still kind of circling back internally, after the impact of the mid-April announcement, especially in the infrastructure pillar. So I'm probably going to need at least a couple of weeks to hear back on resources and next steps. So just wanted to give a quick update over here. And I just wanted to ask, so those are just general updates in terms of progress in other areas. Is there anything that's not being covered by the topics that we went over today that should potentially be something that could be a part of the door heat exchanger community efforts? Because I know we have we have folks who've been joining the call, and so I just want to make sure that everyone's opinion is heard over here. So if you believe the door heat exchanger community is missing a gap somewhere, please let us know. And we may not be able to work on it immediately, but we can definitely put it in the pipeline and set up a way to get to it eventually.
John, one question. Last year I was for a couple of months away, and I don't know what happens with the revision to the specification, to the requirements document to OpenRAC v3. It was an update, or Andreas Maya was working in an update for that, but I don't know the stand of this document.
Yeah, so that was, you're right. So that was the specification. Actually, that's a great point. On that one, I was hoping, to be perfectly transparent, I was hoping that we could probably use the facility door heat exchanger effort as a springboard to maybe define a specification, because then that way, a lot of that would cover what would need to go into the specification. Because I think a lot of what would need to be put into place to enable a facility door heat exchanger could actually apply to a frame that can be mounted to OpenRAC v3 to enable door heat exchangers that are mounted directly to the rack. So I'm thinking, specification work can potentially be a follow-up area. Yeah, so I'm not entirely sure if this is something that could be covered by the global summit, but it could definitely be one of the sort of future effort areas for sure.
Yeah, and yeah. Also, it's important to define the interfaces between the rear door and the CDU or the rack. Once we have the OpenRAC v3 defined, we can define also the connections and the place we can use to connect everything inside between the rack and the rear door.
Correct, and that's why I was saying, this facility door heat exchanger effort will anyway have to talk about these interfaces, right? Okay, how do you get power to the door heat exchanger from the rack? How do you connect the door heat exchanger to the,
facility
to the rack management? Yeah, to the rack management device in the rack. Where should the liquid cooling interfaces be positioned? So, you could potentially do an in-rack manifold, a blind mate manifold, or do in-rack CDU, or so on and so forth. So I agree.
Yeah. This, I think, is a very important topic.
Yeah. Anyone else?
Hi, that's Ben Tsai. I just wanted to introduce myself. I was kind of a fly on the wall here. Just enjoying the meeting last month on the 27th. Primarily just to listen in, see where this work group was going. But I think that last bullet was particularly important to us, right, as consumers of this hardware. Like, again, how does this heat exchanger interface with the rear of the rack? What sort of hooks might be in place? How would we manage it? What would we need from connectivity to either to the CDU or directly to primary water, right? I think that's very, very pertinent to us.
Awesome. Yeah. So first of all, thanks for introducing yourself, Ben, and we appreciate you joining the Door Heat Exchanger calls. If you don't mind me asking you a question, obviously it says that you're from Dell. Uh, are you guys looking at this in terms of adopting the open compute I guess solutions like OpenRack v3, or would you also like to see support for other rack standards like EIA 310 or Open 19 or so on and so forth?
Oh yeah, so absolutely. So I think this is at least coming to this meeting is specific to RV3. There's a certain family of platforms that we're looking to launch to these this new form factor. Obviously, this is more solution oriented, right? So we're trying to get our arms wrapped around the overall rack level solution. These will be liquid cooled. So again, an understanding, the manifold, blind make quick disconnects, bus bars, etc. And where we believe we are going with our platform relative to where the specifications that are been written so far are, right? And we think at this point there's quite a gap between our needs and let's say the needs of Meta, right? So how do we resolve that? And I think there's means, we don't want to go too far off the script. We don't want to create these bespoke solutions just for Dell. We want to maintain the spirit of OCP and try to figure out ways to, let's say, consume as much as we can of the standards, and if need be, sort of influence those standards, because we believe there are probably a lot of other OEMs like us that would love to adopt ORV3, but it's just there's just a still quite a gap between what we need and what the rack can provide, right? So as I think just sort of spitballing stuff here, since you've asked the question, right? We're looking at power densities far greater than Meta, right? So we might need 6 power shelves. We might need something on the order of 10 whips, to power all those shelves. We think our I/O will require far more inter-rack cabling than the front I/O space will provide, right? So we've actually been talking to Juan Carlos and Rital and others to try to figure out, well, how do we resolve this? Because again, we're going to push this well beyond, I guess, the intent as it's written today. But is there a way to again sort of influence things so that we're can meet sort of a greater market with than the original intent of the spec as it stands today.
That's awesome. Yeah. I mean, your comment about high density cabling is on point, right? And I think that's where maybe you guys' interest in blind made liquid cooling probably originates, right? Is because front panel real estate is so lucrative. If you can do power and liquid from the rear, right, then at least you don't have to worry about that when you start thinking about what needs to take place at the front panel. So yeah.
Yeah, absolutely, right. And if you think of again, if anybody's seen what we've deployed so far in the current 19-inch EIA form factor, right, these are all manual connections for, let's say, power for liquid cooling, right? To the manifold, these cold plate loops, we basically use a hose coming out of the back of our servers that are manually connected to the manifolds at the rear of the rack. Once you stack you know, especially in our high density, we have 4-node 2U, right? That is a particularly dense compute platform. You stack that, you know, 40U high, and you start to run out of space. You know, the real estate in the back of the rack is really at a premium, and we're already pushing, you know, like 750 millimeter wide, but 1200 millimeter deep racks, and we just start to run out of real estate, and they get, you know, particularly power hungry. And now we're trying to foot in PDUs that, you know, I might need 4 of them just because of, you know, the port count needed, the ampacity needed, the, you know, our hit limits on breakers, you know, you name it, and this stuff just doesn't fit anymore, right? So we're working through all these challenges, and you know, this open rack standard is particularly appealing. But even still, as we dig into it more and more, there's like, okay, well, there's still some things that miss the mark. And, you know, again, if we can influence that, I believe, you know, there's, you know, some potential for, you know, again, greater adoption of the standard across, you know, multiple OEMs.
Yeah, absolutely. And, you know, yeah, thanks for bringing that up. I mean, you know, for a long time, we've wanted someone to comment on the integration side, right? I mean, we can talk about solutions, but as to how these solutions come together with hardware, you know, and as you've said, you know, and even I, as an employee of Meta, don't want this to be Meta specific. So yeah, I do appreciate you bringing this up, and you know, if you can help us sort of bridge those gaps, so we can ensure that all these OCP contributions are, you know, can be more widely adopted, I think that would be great. So yeah, thanks for being here, and you know, hopefully you can help us achieve what you know, what would be useful to the wider community, including Dell.
Great, yeah, happy to be here and happy to help however I can.
I do have a quick question. When you talk about higher power at the rack, what sort of kilowatts are you? Because you know, you did talk about 6 power shells and, you know, 10 AC whips and so on and so forth. But you know, if you don't mind talking in a general sense, like how high does this get?
Yeah, so
I mean, roughly,
so I'm not
ballpark,
averse. Yeah, you know, over 200 kilowatts per rack.
Wow. Okay.
Right, and you know, with DLC, and let's say you're picking up, you know, somewhere, I'm just going to make up a number, 60% of the heat into the liquid. That still means I've got 40% of that 200 plus watts into the air, right? And again, that's where some sort of rear heat exchanger solution, I believe, will be quite appealing for our customers. You know, and then again, we have to think about it holistically, right? About, you know, what are we picking up with the DLC? How do we manage all that? How do we, you know, scrub the heat if we want to have a room neutral solution? You know, and then all the integration tasks that occur. So, you know, our typical model is to provide the entire solution to our customers rather than having them build and rack and stack it themselves. That's, you know, it's part of our value proposition, definitely, especially when you talk about liquid cooling, and sort of the trepidation that customers have around this. You know, they believe there is a value that Dell provides if, you know, we can validate all this stuff prior to it leaving our facility, such that, you know, it's more plug and play, if you will, by the time it gets to the customer site.
Yeah, awesome. I mean, you know, if you're talking about a 200 kilowatt rack, you know, and yeah, I agree with you. You'd probably want a large portion of it to be liquid cooled with cold plates. But you know, you can't get away from air cooling. But yeah, 80 kilowatts of air cooling in a rack, that's going to be a lot of fan power, and you know, and I would anticipate a pretty noisy solution. But you know, at the end of the day, you know, the question is, what's the driver, right? If the driver is density because you want to minimize interconnect distances, right? Especially with HPC and so on and so forth, then, you know, then the question is, how do you enable that? And, you know, cold plates, hybrid cooling, right, as we call it, which is cold plates plus door heat exchanger, is definitely a great way of enabling high power racks. That's for sure.
Right.
Awesome. Yeah. Thanks for being here, Ben. And I might reach out to you offline to maybe chat about this a little bit more. So I'll probably ping you on LinkedIn or something like that. Thanks.
Sure. Yeah, that sounds great. And I'm in the Austin area. I think you talked about Texas earlier, so. And I assume
Yeah, I'm in the Bay
data
Area.
center
I have
world.
yeah. We do have a hardware presence in ATX. So if I ever find myself in Austin, I'll definitely reach out to you.
Yeah, please. I have a few friends that work at Meta that I would love it to reach out to. One of which is Daryl Daniel, actually, who I think influenced the ORV3 specs. Need to
Yep,
go talk to
that's for
him.
sure. Yeah, yeah. Awesome. Anyone else? All right. If not, I'm happy to give 10 minutes back. Thanks all for joining the call and talk to you all soon. Thank you.
Thank you.
Thank you, you too.
Thanks,
Bye
John.
bye.
Bye bye.
Thanks, everyone.